Swayam Prabha. Digital India. Educated India.
Welcome back to another session on engineering system design. In the last lecture we discussed about the functional decomposition and how to use the IDEF0 template to decompose the functions into its sub functions. As mentioned earlier, IDEF0 is a standard developed by US Air Force for development of engineering systems, and this can be effectively used for functional decomposition. It actually uses a graphical format as well as text format to represent the functions and their decompositions, and once we get this decomposition or the sub functions, we can use it for developing a functional architecture or a hierarchical function structure. We discussed about one case study, that is of an elevator system design, and then how to use the IDEF0 diagram for decomposition of the elevator system. Today we will discuss another example, a practical case study or a practical example, and use the IDEF0 diagram to decompose the functions into small functions. So the example here I am using is a unified data recording system, or it is known as UDARE. Basically this is used to record the data of educational institution, especially the attendance, the score, the grades, and all other activities related to the scholarship, then the stipend, fees details, and apart from that it can actually act as a data recording system as well as an information database, where students as well as the staff and faculty can use it for various other purposes. So the main objective of this system are: one is to basically online recording and compilation of attendance for students, staff, faculty on a day-to-day basis. The other one is to do a real-time analysis of a slot-wise engagement of students and faculty, basically to find out whether the students are free on a particular slot or a faculty is available on a particular slot for a meeting or for some other classes. Serve as a real-time database for leave, salary, scholarship, etc., and the computation of these data. It serves as a real-time database for students' feedback on courses and feedback analysis, and it serves as a real-time centralized database for fees records of all students, and a real-time database for venue allocation time slots for year-long literary or social activities happening in the institutes. So this actually acts as a uniform database and can be used for various purposes. Apart from the academic activities, it can be used for other cultural and social activities also. So if you look at this system, you can actually see that it actually encompasses many subsystems and external systems, and it requires a system approach in the development of the whole UDARE system. If you look at the external system diagram for this particular system, then you can see that the students, staff, faculty, internet provider, main server, and maintenance personnel, these are the external systems directly interacting with the main system of UDARE system, and the UDARE system will provide the services which we already discussed, and there are many other functions taking place. The customers or the users will ask for the services, and various forms of requests will be there, and there are other external system like software regulations and building regulations which will be acting as an external system for this system. So when we develop the UDARE system and try to decompose the functions, we need to clearly identify the external system separately and then look at the main function or the UDARE function only during the functional decomposition. So these are all the external systems. So the external systems will be having their own functions, but we should look only at the interacting functions or the interface functions which actually will be used for interfacing the external systems to the main system. So this is the external system diagram for the UDARE system. Now if you look at the context diagram or the A-0 diagram of the IDEF0, you can see that the inputs and outputs are mentioned here. So, there are many kinds of inputs about the user interface in terms of password and username, then the attendance details, the information regarding the grade and the scholarship and fees, then other events schedule, and then the slot wise listing of courses. So, these are all coming as input to the UDARE system, and there are many other outputs coming from the system, basically the updated attendance, the mail request for slot exchange, then scholarship allotment and renewal data, then updated LeadSoc allotment database, recorded staff attendance, fees database, all these things are coming as output, and you will be having many control inputs which are not shown here. Control input in terms of the availability of various classrooms, availability of the fee structure and the scholarship structure for different category of students like MTech, PhD, BTech, and these are all the control inputs coming to the system. And of course, the mechanical system will be the UDARE system or the main hardware which is used for providing this service. So, this is the context diagram from this system. Now, this context diagram, you know that A0 is the main function, provide UDARE services is the main function. Now, we need to see how to decompose this into its sub functions. So, that will be coming in the first level diagram or the A0 diagram. In A0 diagram, we will try to decompose these functions into A1, A2, A3 and etc. That is depending on the number of sub functions, we will divide this into many functions. So, you can see here the main function provide UDARE services, this can actually be decomposed into 4 sub functions of the main function, that is user identity for authentication, accept user request, provide services and maintain services. So, these are the main 4 functions. Now, if you write the A0 diagram here, user identity authentication is A1, then accept user request, provide feedback, control operation, provide utility services and maintenance and repair. These are the 5 functions which actually can be obtained from the A0 diagram. Now, if you look at the various inputs and controls coming into this system as well as the output, you can see the data search request will be coming from the user, and then there will be a network database which actually uses the username and passwords, and there will be other requests for coming from users like navigation request, then transaction request and then maintenance, and all these inputs will be coming over to these functions like user identity authentication, and that will be giving a feedback to the customer about whether the request has been accepted or the password and username is approved, and then other requests from this data will be given to the next function which is accept user request or provide feedback, and again there will be many requests coming from here, the data search request, various kinds of requests will be going to this function also, and there will be a feedback going from the system to the output. And the third function which is control operation. In control operation, which is the A3, third function of the main function. So, control operation is basically to control the use the input data or the output from these 2 functions as well as the data request, and then control signals will be used here to control the operation, and based on that the utility services will be provided by the system. So, this is the 4th function, and of course, maintenance and repair will be a additional function which will be actually having the output from all these functions about the malfunctioning of any of these system data. This system will be sent to the maintenance and repair function, and here the any output regarding the functioning of the system will be provided, and this will be given as a feedback to other systems also, so that any malfunctioning of the system can be easily recorded as well as given as an output to the user. So, this is the first level of decomposition or known as the A0 diagram. Now, if you decompose one of these functions to its sub function, we will be getting the A1 diagram. In A1 diagram, we will actually so this is the detailed explanation for the previous diagram. As you can see here, this is the user authentication A1, and this is the A2 function, and this is the A3 function, and this is the A4 function and then A5 function, and all the outputs from these blocks are shown here, like provide utility services. So, the various utility like data display, navigation services, cashless transaction, all those outputs will be provided by this particular function. First level diagram. In the first level diagram we will be decomposing the A3 function into its sub functions. So, you can see here. So, A3 function is basically to provide the control operation. So, in control operation we need to control the request from the users, and then basically based on the request we need to provide outputs. So, here you can see this A3 function, A3 has got many sub functions, basically process request which actually process the request received from the customers or the users, and then search for data based on the request. The data will be searched for the requested information, and then it will be extracting the data and then be providing it to the provide service function. So, these are the 3 sub functions of the A3 function, and that is the level 1 diagram. So, here you can see the data search request, navigation request and cashless transaction request, all kinds of requests from the users which will be coming from the in terms of in digitized format to this function, and here this will be processed, and the processing information, based on the processing information a feedback will be given whether the data it is possible to provide the service or not, or is there any malfunctioning of the system. And then that information, the processed information will be sent to the database for searching for the data, and whatever the data is obtained will be given to the extracted the data and will be given as an output to the next level. So, A4 function or to the outputs. So, this is the level 1 diagram, and as you can see the network database will be used as an input here, and other input requests will be also used. Of course, power supply and other control inputs also will be coming to this in order to provide the service. Again, further dividing this function, if you want to go for further details and to see what are the other functions needed to provide this particular any one of these functions. So, we can take A32 as a function and then try to decompose that into further level. Okay, this again detailed description of the previous diagram, A3 diagram. As you can see A31 functions here, A32 function and then A33 function. So, these are 3 sub functions of A3 and their control and interaction are shown in this diagram. So, you can see the various feedback and outputs, provide navigation details, display information and transaction details, all are shown over here. Now, if you decompose this function further A32, then you will be getting the 32 diagram, which is level 2 diagram. In level 2 diagram we will try to decompose the function A32 to its subcomponents. So, we can see that here A321 and A322 are the 2 sub functions of A32. So, in A32 connect to the network is basically to search for data. So, connect to the network is one function, and then search for desired data in the network database is another function. So, these 2 functions will provide you the data which is needed to provide the service. So, the extract data from the network will be the output from this block. Again the login and password information will be provided in order to search the network database, and then the desired data will be given to the next level function. So, this is how we decompose the function A32. Now, if you want to decompose this further, we can actually decompose this into the next level. So, 321 or 322 can be decomposed into level 3 diagram, and this actually shows the detailed explanation of the previous one, the diagram A32 diagram. So, connect to the network is A321 and search for desired data in the network is A322 diagram, and the output is extract data from the network. So, we will go to the next level of decomposition where A322 is decomposed into its sub functions. So, that is known as A322 diagram, and this is a level 3 diagram, and in this case the A322 function is decomposed into 3321 and 3322. So, here the 332 function, the first subdivision is find the category of the information asked by the user, and then the second is collect data from the corresponding category. So, depending on the category the data will be collected from the corresponding category. So, we can see that A322 function has got 2 sub functions, and the main output is coming from the function A332 A22 which is the data extracted. So like this if you go by level 0, level 1, level 2 and level 3 diagrams, we can actually keep on decomposing these function into each sub functions, and to what level we need to do this is actually determined by the type of function, but in general we go up to level 3 or level 4 functions, and by that time we will be having a function which need not be decomposed further, or a module or hardware form in the form of a hardware or in terms of a software will be available to provide this function. So there we actually stop the decomposition, like collect data from the corresponding category. So this actually can be easily implemented using a software code. So we do not decompose this into further because it is easily understandable at this level. In case it is not so easy to understand, or if you feel that there is a need for further decomposition, we can go to the level 4 diagram or level 5 diagram, but that actually depends on the situation and the understanding of the function by the person who actually develops the functional decomposition. So this is how we actually use the I0 diagram to decompose the main function into its sub functions. This again shows the same previous diagram in more clarity, that A3321 function and A3322 function are shown here in this diagram. So once we have this decomposition, basically what we did was to take the main function and then see what are the sub functions needed for this. Those functions are identified through the decomposition through I0 diagram, and once we have these sub functions, we need to represent it in a hierarchical format. What is the top level function, what are the level 0 function, then level 1 function, level 2 functions, like that, and that is represented in a hierarchical way. Then we will get the hierarchical function structure, and that is what is shown here. So you can see that level 0 is provide UDARE services. So this is the function for providing the main function, that is the UDARE services. So that is the level 0 diagram. Then this level 0 diagram was decomposed into 5 functions, basically user identity authentication, accept user request, provide feedback, control operation, provide services, and maintenance and repair. So you can see that A1, A2, A3, A4, A5 are the level 1 functions, and then these level 1 functions, each of these functions can be decomposed into its sub functions like A11, A12 or A21, A22, A23, etc. A31, A32, A41, like this it can be decomposed. In this case study we actually decompose the function control operation A3 into its sub functions like A31, A32 and A33, where process request, search data and extract data were the sub functions. Again each of these sub functions like A31 can be decomposed to A311, A312, A32 can be decomposed, similarly A33 can also be decomposed into sub functions. Again we can use the I0 diagram to do this decomposition. In this A32 function we decomposed, and then we found that A321 and A322 are the 2 sub functions, basically connect to network, search for data in the database. So these were the 2 sub functions. Again the function A322 was decomposed to A3221 and 3222, and similarly this can be subdivided if needed. We can go for lower level functions and decompose it to further. So this actually shows a hierarchical function structure. Now if you want to provide this particular function, we can identify what are the lowest level functions to be provided in order to provide this function, and this actually helps us to identify the proper hardware in order to provide this function. So this is the basic way of decomposing the functions into its small functions and showing them in a hierarchical way, and this is known as the hierarchical function structure for a system. So this actually shows more clear view of the function. So the provide UDARE services is the main function, and these are the sub functions A1, A2, then A3 and A4 and A5, and then you can decompose this A3 function into its sub functions A31, A32, A33, and then further down we can go for A3 can be decomposed into A32 can be decomposed to 321, 322 and so on. So we will be able to decompose all these functions into its smallest level functions and provide the hierarchical function structure. So that is how we do the decomposition. So some of the common mistakes in developing the functional architecture are we actually have different format or different methods to do the decomposition. Basically we discussed about Hartley-Pirby template and IDEF0 diagram, and in both these methods some common mistakes normally happen because whether the students or the engineers, they try to include the external systems and their functions as part of the main function, and this is one of the reasons we define the external system in the beginning itself. We clearly state that the external systems are outside the boundary of the main system, and therefore no external system function should be included in the functional decomposition. Similarly, choosing the wrong name for a function. So always the function need to be expressed in terms of a noun and a verb, and if you use it in a different way, then the actual the meaning of the function will not be clearly understood, and therefore we make mistakes in the further decompositions. Therefore we have to choose the correct name for the function, and then creating a decomposition of a function that is not a partition of that function. Again, we cannot have a function which is already a main function as a sub function again. Therefore when we decompose the function, we should be very careful, and we should not do a function which is not a part of the main function. So make sure that all the functions are really part of the function being decomposed, and then violating the law of conservation of inputs, outputs or controls. Basically as you can see in every function there is an input, there is an output and some control functions. So all the inputs should actually come out of the system as an output in form of by suitably processing using the control. So the all the signals which actually goes in and the out, there should be a balance, and there should not be something which is completely absorbed in the function. So that is actually against the law of conservation of inputs, outputs or controls. So these points need to be taken into account while decomposing the function, and make sure that we do not make the common mistakes this functional decomposition is very prone to have. So follow these rules and then try to avoid the common mistakes. That is about getting the functions basically from the main function of the system. But apart from these functions, we need to have some additional functions in the functional architecture. So in order to finish the functional architecture, we need to look at a few more additional functions which are not very obvious to the designer in the beginning, because we always look at the user request and then processing the request and providing the output. So in order to make this happen, we need to provide additional functions also in the system, and here what we need to look at is basically the system errors and then identification of the errors in the system. So in order to finish the functional architecture, we need to define the system errors and the failure modes and inserting functionality to detect the errors and recover. So apart from providing the services, we need to have the functions in the system in order to make sure that the system is working perfectly well, and as well as it actually identifies some errors in the system or faults in the system and it is reported. So the functionalities are needed to identify these faults. That is the fault identification functions. And the other one is inserting appropriate functionality for some combination of built-in self-test and external testability. So there should be some test going on within the system which is known as built-in test to make sure that the system is performing well throughout its life, as well as external testability is possible, that it is possible to test the system using some external resources or external means. So the functions to be provided in order to provide these functions also. So if we add with these functions along with the previous functional architecture, then only the functional architecture is complete. Now how do we provide these? So in order to provide these functions, we need to define some of the terms which actually define the fault identification. So we define these functions as error detection functions. So these are the functions to be provided, they are the error detection functions. So in order to find out the function or how to provide this function, we need to define these terms like failure. A failure in a system is defined as a deviation in behavior between the system and its requirements. So, every system has got some requirement identified by the users or the stakeholders. So, whenever we are not able to provide this requirement, then it is known as a failure of the system. So, any deviation in behavior between the system and its requirements are known as a failure. An error is a subset of the system state which may lead to a system failure. So, every system has got a system state. We defined the system state in one of the earlier lectures. Basically, it is a snapshot of the system characteristics at a particular time. So, subset of the system state is an error which lead to system failure. So, any changes in the system state or which is not as per the required state, then this may lead to a system failure, and subset of the state is known as an error. And a fault is a defect in the system that can cause an error. So, any fault in the system in terms of its physical behavior or a malfunctioning of a physical component, this can actually cause a defect, and that will cause an error in the system. So, these are the terms which actually comes into play when we define the error detection functions. So, the basic idea of providing the error detection function is to provide fault tolerance in the system. So, fault tolerance is the ability of a system to tolerate faults and continue performing. So, every system should be able to tolerate the faults in the system and still continue performing. So, even when there is a small error and it actually results into some problem, the system should be capable of continuing the performance without affecting its outputs or the performance requirements, and that is known as the fault tolerance in a system. So, you look at the fault tolerance terminology map shown here, you can see that there are observable and unobservable failures in the system or the errors in the system. So, every system has some requirements, and these requirements are the basic objective or output of the function or the system, and then system may have deviation from the requirement. So, there are requirements for the system and there may be a deviation from the requirement, and this is known as the failure of the system, and the system as such cannot observe the failure. So, because the system does not know what is it supposed to do, only the customer will be knowing or the consumer will be knowing what it has to do. So, the system as such cannot identify its failures. So, that is why these are unobservable failures, but we need to convert this into observable quantities, then only we will be able to correct or have fault tolerance in the system. So, you can see a system has many states, and states may have errors, and these errors are observable. These are the errors which actually lead to failure. So, we look at the system state and then these errors, and since these errors are observable, we look for observable errors and then try to observe the error and then provide a fault identification or fault tolerance function. Again, the system may have defect which is a fault, and this can actually cause errors. So, the basic culprit here may be the defect or lack of providing the requirement. So, any one of these can actually be observed through the errors, and then these errors can be monitored, and necessary functions can be provided in the system in order to provide the fault tolerance, and these functions which actually provide this fault tolerance are known as fault tolerant functions. So, fault tolerance can be achieved for those errors that are observed. So, there are many functions in order to provide the fault tolerance. Basically, if you look at the fault tolerance function, there should be an error detection function basically to detect an error, if there is an error or not, or when something goes wrong, the system should be capable of identifying the error, and then only we can actually tolerate that particular error. And then there will be a damage confinement. Basically, when there is a damage, we need to make sure that it is not spreading to other areas. So, this is known as damage confinement. And then error recovery. So, if an error happened, how do we recover from that particular error? That is known as error recovery function. And then fault isolation and reporting. So, we can see here fault isolation and reporting is the final one. Basically, you isolate that particular fault and report to the maintenance function or the maintenance module, so that you can take the corrective action. So when all these 4 functions are provided, when you have the error detection, damage confinement, error recovery and fault isolation and reporting, then we are getting the fault tolerance in the system. And this can actually be provided by in different ways. Different functions can be incorporated into the system in order to have all these 4 functions, and when we add these functions into the function architecture, then the fault tolerance function becomes possible in this particular system. So error detection, as I told you, the first function is error detection. This is defined as, error detection is defining possible errors or the deviations in the subset of the system state from the desired state. As we know that an error is basically a variation from the system state from the desired state. So we actually define this using the error detection function in the design phase before they occur, and establishing a set of functions for checking for the occurrence of each error. So we know the state and we know what are the states to be observed, and we define some functions or a set of functions for checking the occurrence of each of these error. So normally the functions are type checks, range checks and timing checks. Type checks is the type of data, whether it is an integer data or a floating data, or it is some other kind of data, digital data or an analog data, or the range checks. So what is the range of data expected from that particular output, and if it is crossing the range, then an error will be detected or an error will be reported. Similarly timing checks. So if you do not get a particular output from a source in a particular duration, then error will be declared. So these are the different types of functions provided in the system to have error detection: type checks, range checks and timing checks. And damage confinement is protecting the system from the possible spread of failure to other parts of the system. So if there is a failure, and this failure should be protected or failure should be prevented from spreading to other parts of the system, and this is known as damage confinement. Normally firewalls are provided in order to prevent this happening. So whatever the damage, it will be confined to a particular region only, and it will not spread to other areas. So that is damage confinement. The other one is error recovery. Error recovery attempts to correct the error after the error has been detected and the error's extent defined. So once the error has been detected and its extent defined, then it will start recovering from this error. So there are many ways of doing it: backward recovery or forward recovery. Backward recovery is basically it will go back to its previous state where there was no error, and then try to take that data and then go ahead with the that data and continue its calculation or continue the processing. So that is known as backward recovery. In forward recovery, it will try to see the next correct data, and from that point onwards it will take the data and then start processing. So this is known as forward recovery. So any one of these can be employed depending on the system to provide an error recovery function. And the last one is fault isolation and reporting, which actually attempts to determine where in the system the fault occurred and that generated the error. So this is basically to find out the source of error. So it will try to determine the point where or the place where the actual error occurred, and that will be reported. So that is the fault isolation and reporting, and there are many ways of doing this. You can do it using software, or you can use using hardware. In the next chapter we will discuss about how to provide these functions using hardware, or what kind of hardware can be used for fault identification or isolation reporting, as well as for other functions of error recovery and error reporting, as well as prevention of the error from spreading. So all this can be done using hardware or software. So these are the main functions to be provided in order to have a fault tolerant system. So the functions for error detection, damage confinement, error recovery and fault isolation and reporting should be included in the functional architecture, and these functions should be defined for each state variable of the system. So depending on the number of state variable, we will be defining the functions for all these 4, that is error detection, damage confinement, error recovery and fault isolation and reporting for each state, and make sure that it is possible to have a fault tolerant system for all these important states of the system. Okay, so that was about developing the functional architecture using methods of HP template and IDEF0, as well as including the functions using fault tolerant system. So, we can actually incorporate all these functions in the system and identify all these functions in the system and provide a functional architecture. So, apart from identifying the functions, this functional architecture can be used for identifying the requirements or tracing the requirements to the functional architecture. We know that there are different requirements and we have provided different functions. Now, we need to ensure that these functions are sufficient to provide the requirements, or we can actually trace the functions or the requirements and then associate the corresponding functions to these requirements. So, elements of the set of input output requirements should be traced to appropriate functions that have been defined in the functional decomposition. So, when we have these input output requirements, we need to find out, okay, which function is basically satisfying this particular requirement, or which are the functions which actually can be used for satisfying the particular requirement. So, that can be obtained using the functional architecture, or we can use the functional architecture to trace these requirements, or to find out the relationship between the requirements as well as the functions provided in the system. So, for this we will use a chart which is basically we will show the functions here and the requirements. I will show you a more detailed diagram. So, you can see here, this is how we actually trace the requirements. So, we write down the requirements here. So, suppose you take the provide elevator services as one requirement, accept passenger request and provide feedback will be one function of this. Then support waiting passengers, support riding passengers, support emergency passengers in emergency, and control, these are the sub functions. We need to sub requirements, basically these are the requirements from the customer. So, we need to find out which are the functions actually satisfy these requirements. So, if you look at the provide elevator services, we can see that there are many functions. The elevator system shall receive calls for up and down service from all doors of the building. Then the elevator system shall receive passenger activated fire alarms in each elevator car. The elevator system shall provide adequate illumination. These are the requirements of the customers. The elevator system shall open and close automatically upon arrival at each selected floor. The elevator system shall control elevator cars efficiently, and then elevator system shall use a phone line from the building for emergency calls. So, these are all the requirements from the customer. We need to see how these requirements are satisfied by providing the functions. So, this actually support waiting passengers, support riding passengers and support passengers in emergency, these are the 3 sub functions we provided, and we can see that the elevator system shall receive calls for up and down service from all floors are satisfied using these 3 functions. So, these 2 functions provide elevator services function satisfy the requirement of elevator system shall receive calls. This again it satisfies this requirement also. System shall receive passenger activated fire alarms for an emergency case. Similarly, system shall provide adequate illumination. So, all these functions, if you look at these functions, you can see that all these functions are used for satisfying the provide elevator service requirement. Similarly, we can actually find out other requirements like control elevator cars or move passenger between floors. We can identify which are the functions, which are the requirements satisfied by this function, or which are the functions basically satisfying this requirement. You can look at this, the elevator system shall provide adequate illumination is one requirement. We can see that there are 1, 2 and 3 functions are there which actually satisfy this requirement. So, we can have this kind of a traceability of the requirements and the functions, or we can identify the each we can take each requirement and then see what are the functions which actually satisfy this requirement. So, apart from developing the functional architecture and identifying the functions, it can actually be used for tracing the requirements also. So, this is only a sample. We can actually take any particular requirement and then see how that particular requirement is satisfied through the various functions. So, this is another advantage or another use of having the functional architecture. So, once we have this functional model or the functional architecture developed, we need to review it by or it has to be reviewed by another person or another individual who actually has got substantial knowledge of the system's functioning. So, whenever we develop the functional architecture, there is a chance that we missed some of these points, or there was an error, unknown error, or some kind of discrepancy in the functional decomposition. So, this need to be analyzed once we have the preliminary model of the functional structure. So, the review should try alternative decomposition. So, we need to see whether we can decompose the function by a different method or disaggregate the functions in a different way, and re-evaluate functional dominance in terms of feedback and control. So, we have some control inputs and then there may be some feedback coming from some functions. So, we have to re-evaluate the functional dominance in terms of feedback and control also. Similarly, catch the interface errors. So, whenever we have different functions, whenever there is an interface between functions, we need to look at the errors which may come up between these interfaces. So, all these can be done in order to review the functional model, and based on this model we can actually refine the functional structure also. So, to summarize whatever we discussed in the last 3 lectures, basically we started with the need for functional modeling. We mentioned about the previous lectures about how do we identify the requirements, and once we identify the requirements, it is the next logical step is basically to convert these requirements into functional structure, that is to identify the required functions which will satisfy these requirements. So, that is where we started for the functional modeling, to make sure that we can satisfy the requirements through some functions, and then we discussed about procedure for doing the decomposition, and we mentioned that there are many methods, like we go for a top down approach or a bottom approach to decompose, and then we discussed about 2 methods. One is known as the Hartley-Pirby template, or known as HP template, and the other one is the IDEF0 modeling, and these 2 methods can be used for top down decomposition of the functions. And then we saw a few examples and discussed how do we use these methods to decompose the functions, and we identified some of the important additional advantage of using this functional decomposition. Basically, one was to evaluate the scenario tracing, to take a particular scenario and then identify all the functions needed for that particular scenario, and then see whether there is anything missing or there is any overlap or redundancy in the function. And we discussed about the fault tolerance functions. How do we actually complete the functional architecture by providing the fault tolerance functions. We discussed about error detection functions, error confinement functions, and error reporting functions, and so on. So, these functions also need to be incorporated into the fault tolerance. And we discussed about the requirement mapping. Basically, how do we map the requirements to the functions using the functional architecture. So, these are the points we discussed in the last few lectures. In the next lecture, we will be basically looking at the possibility of how do we actually convert these functions into physical architecture. Basically, these functions are needed to satisfy the requirements, and once we identify this function, the next task is basically to how do we get a physical architecture for the system which will satisfy the requirements. So, the physical architecture development is the next logical step of system development, and we will discuss about this in the next few lectures. So, till then, goodbye.